Welcome to the Year 12 PPE question 14. Okay, so we have this cubic function here, g of x, y equals g of x, and g of x has a coefficient of x cubed, which is the same as the coefficient of x. We also know it passes through the origin. That means it doesn't have a constant term in the equation. And what else do we know? We know it has a stationary point at 3, negative 36. So somewhere down here, there's a point where the gradient is 0. Okay, it could be a maximum or a minimum. Reading on, it appears that it's a minimum, but we've got to prove that later. So let's start writing something down. So we can say, can't we, that g of x is of the form, okay, ax cubed plus bx squared plus ax, okay, without a constant term. We can also find the derivative algebraically. G dashed of x is going to be 3a times x squared plus 2b times x plus a. Okay, now we have information about this particular point, and that's going to help us now find the values of a and b. So at the point 3, negative 36, we know that g dashed of x, the derivative function, has a value of 0. Okay, so that implies that 3 times a times 3 squared, okay, plus 2 times b times 3 plus a equals 0. Okay, and that implies that, well, that's 3 times 3 squared, that's 27a plus 6b plus another a, so 28a plus 6b equals 0. I'm going to call that equation 1. All right. Now, we also know at 3, negative 36, we also know that g of x, okay, equals negative 36, and that comes from 3, so that comes from a times 3 cubed, okay, plus b times 3 squared plus a times 3, okay, which is equal to negative 36, okay, which implies that, now we can just simplify it, we've got 27a plus 3a, 30a plus 9b. So that gives us 30a plus 9b, okay, which is equal to negative 36. And I can call that equation 2. Okay, now I can solve these simultaneously. So if I just work on that over here, so if I take equation 1 and times it by 3, I'll make this b term 18, you see, in each one. So if I take equation 1 and times by 3, that will give me 28, that'll give me 84, okay, so 84a plus 18b equals 0. And if I take equation 2 and double it, that will give me 60a plus 18b equals negative 72. Now if I do a subtraction, I'll call them equations 3 and 4. Okay, so 3 take away 4. That's going to give me 24a plus 0 equals 0 minus 72, which is 72, okay, which implies that a equals 3, and from one of these earlier equations, b equals negative 14. Okay, and from all of that, we can say that g of x is equal to 3x cubed minus 14x squared plus 3x. Okay, so that's the answer to part A of the question. Now, it says that we've got to determine, or rather prove, that the stationary point here is a minimum. In other words, they're telling us that the curve sort of comes down here to a minimum point and curves off up there. And we don't know what it does after that, but it doesn't really matter. But it has a minimum point down here. So let's see what that will look like. So to show that it's a minimum, we need the second derivative, okay? Because if the second derivative is positive, it's a minimum. So let's do that over here. That's part A. So part B, I'll do that in a different color here. So part B, okay, so g double dashed of x, that's the second derivative, is equal to the derivative of the derivative, which is simply 18x minus 28. Okay, and when x equals 3, okay, g double dashed of x, g double dashed of x is equal to 18 times 3, which is 54, minus 28, okay, which is 54, 30, 24, 26, okay, but anyway, the point is it's greater than 0, so therefore it's a minimum. Therefore, the point 3, negative 36 is a minimum. Okay, and that's all you need to do for that question there, because it's just basically asking you to find whether it's a max or a minimum. Okay, and hopefully that's answered that question.